Hey everyone, welcome to The Explainer. Today, we're unpacking some fascinating insights from Dr. Shukru Imre on a massive challenge in AI right now: how to make agents actually understand business data. Because let's face it, there's a huge gap between an AI just reading numbers and an AI actually knowing what those numbers mean. Today, we're going to bridge that gap by looking at what's called the semantic layer. Let's get right into it.
Here's our quick roadmap for today. We'll be looking at data versus true understanding, the three dimensions of meaning, metadata and business glossaries, managing ambiguity, vectors versus simple dictionaries, and finally, a reliable agent checklist.
All right, kicking things off with part 1, data versus true understanding, or really, how we make sense of the raw numbers.
Imagine you're looking at a raw database entry. It just says, OPO3 Mehmed on leave 0. Now, a human manager looks at that and instantly understands what's going on. But to an AI, that is just random text. It literally means nothing. It only starts to mean something when a semantic layer steps in and gives it a clear business rule, like, hey, do not assign work to Mehmet today. Raw data is really just the starting line.
I absolutely love this analogy from the author because he breaks a complex idea down simply and into plain English. He says the data layer is essentially a dictionary. It just lists the words. But the semantic layer, that's your language teacher. It sits right next to the AI and explains when, how, and in what exact context to actually use those words. An AI can't learn corporate rules just by staring at a spreadsheet. It absolutely needs that teacher.
Moving on to part 2, the three dimensions of meaning and how AI actually processes this data.
When fresh data comes in, a reliable agent essentially has to ask 3 rapid-fire questions. Number 1, what is it? Number 2, what does it imply right now? And number 3, what should I actually do about it? Let's break these dimensions down.
The first dimension is meaning. The AI needs the basic raw facts. Say it sees the number 196. Well, 196 what? Kilograms? Meters? The semantic layer steps in and tells the agent, okay, this represents cubic decimeters. It's a unit of volume, and by the way, the valid range here is 1 to 2,000.
Then we have the second dimension, context. This is all about linking terms together. Think about HR data. The terms on leave and sick are totally different words, right? But context teaches the agent that, practically speaking, they mean the exact same thing. This person cannot be assigned work today.
The third dimension is the rule, and this is the real game changer, because it turns the AI into an active decision maker. If your local labor laws state that an operator can only do a maximum of 10 tours a day, the AI learns that hitting 11 is a legal violation. Suddenly, the agent isn't just reading data, it's actively flagging risks before they even happen.
So how do we actually build this out? That brings us to section 3, metadata and business glossaries. Basically, the AI's toolkit.
Tool number 1 is metadata. You can think of this as an ID card for every single piece of data you have. The system's always going to ask, is this entry valid? And what on earth do I do if it's completely blank? Metadata answers those questions, telling the system exactly what kind of field it's looking at and the fallback plan if something is missing.
Tool number 2 is the business glossary. This is your company's official dictionary. It is absolutely crucial for eliminating confusion, ensuring the AI agent understands your internal jargon the exact same way your human employees do.
For instance, take a simple word like tour. To your warehouse operations team, a tour is a collection trip. But ask the logistics guys, and a tour is a delivery route. Ask accounting, it's a billable unit. Without one unified glossary, those different teams would completely confuse the AI with 3 totally different definitions for the exact same word.
Which segues perfectly into section 4, managing and resolving ambiguity, or what happens when rules collide.
Your system has to act as a referee for 3 main types of ambiguity. First, lexical ambiguity, when the same word has completely different meanings. Second, contextual ambiguity, when the same value implies different things. And finally, rule ambiguity, which is when 2 important business priorities directly clash with each other.
To solve those rule clashes, the AI needs a very strict, uncompromising hierarchy. Legal compliance is always priority number 1, no exceptions. Then comes high-priority tasks, followed by workload balance, and then volume balance. So, if balancing the workload would accidentally cause illegal overtime, the AI immediately drops the balance rule to stay perfectly legal.
It resolves the conflict completely on its own.
All right, part 5, vectors versus simple dictionaries and how to choose the right engine.
Now, standard large language models usually rely on complex math, things called vectors or embeddings. They convert text into numbers to essentially guess at meanings. And hey, that's fantastic for open-ended free text. But for structured warehouse data, like an HR status saying sick or a location called A block, we definitely don't want the AI guessing. For that, we use a simple, hard-coded dictionary.
By using dictionaries for your structured data, the AI's decisions become strictly defined. There's zero guessing, which means zero hallucinations. It's fast, it's totally predictable, and most importantly, it's super easy to explain in plain English to any human auditor who asks why the AI made a certain choice.
Let's wrap this up with Section 6, the reliable agent checklist for building your own semantic layer.
If you're building this out, here is your checklist. First, clearly define your units and valid ranges. Second, establish your official terms in one unified glossary. Third, enter your business rules and, crucially, prioritize them for conflicts. Next, decide up front how to handle missing data. And finally, stick to simple dictionaries for structured data, saving those fancy vectors only for free text.
So our agent now has a dictionary, it has its rules, and it can referee conflicts. But how does it actually connect all these concepts together? How does it know that one tiny constraint might trigger a massive chain reaction of decisions? Well, that requires something called a knowledge graph, but that is a whole other rabbit hole for next time. Thanks so much for joining this explainer, and I'll catch you in the next one.